Okay, welcome everybody to lesson 10 for Education for Nepal English Group. This is our YouTube channel for past lesson recordings. And today we'll be teaching computer science, pop culture, astronomy, and music. So today we'll start off with computer science, where we'll be talking about recursion. So recursion is like a special type of function where it calls on itself. Like that's the most important part about recursion. A recursive function will call on itself, usually multiple times. So one example is this sum function that I've written here. And what it does is it adds up all the numbers from 1 to x. Now you could do this with a for loop or a while loop, but I just chose to do this with a recursion to show you guys here. So in the function, you can see that while x is greater than 0, it'll return x plus um, the function call of x minus 1. So this will be really confusing if you like think about it, but I believe in you guys that you guys can get it. So what it does is that you guys know that every function has to have a return, right? Unless if it's like a void function. But here we have a in return type of integer, so we must return an integer every time. So what we're doing is that we're returning x plus um, x minus 1, which is the one smaller than it, right? Because like we're like going down from x all the way down to 1. And then we basically, let's say we x is 10, then we go 10 plus 9, then 9 plus 8, and 8 plus 7, all the way down till when x is 0. That's when we return 0 because now we go to the else part of the if statement, and we kind of climb our way back up. We go 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 and then plus 10. So then it'll sum up all the numbers from 1 to 10. But yeah, explaining recursion is really hard. You kind of have to just read the function for yourself and like plug in a number and try it, and then you'll probably understand it. So recursions, like loops, need an end condition. Like when we have a for loop, we have when I is less than this value. So, or if we have a while loop, we usually have a Boolean inside the parameter for the while loop. So we have true and false, right? So when it's false, the while loop will end. And it's the same thing with recursion. So here I have the same recursive function against sum, except I've shortened it a lot and I've removed everything except for that return line. But now my recursive function actually won't work because it'll never end and it'll run infinitely. Because if we don't have an if statement like I did earlier, there's no real end for this function because x will infinitely decrease by 1. Earlier, I had if x is greater than 0, so it would stop at 0, but now it wouldn't stop at 0 because there's no if statement. So recursive is very confusing, and so why would people use it, right? So it does have it. Recursion does have some advantages. Like for example, it makes your code shorter and easier to read. Like instead of writing a function or calling a function many times, we can just write one recursive function to simplify all that, right? So like earlier for the sum function, instead of calling sum, if we just wrote a regular sum function where I just return x plus x minus 1 and that's it, and let's say x is 10, right? Then I would need to call that function like 9 or 10 times, which would be really which would be really like uh tedious, right? Because you'd have to write so much extra lines of code that are like unnecessary. And then some problems also need to use recursion, and we'll talk about these probably like next week, such as traversing a tree or like using DFS or BFS. And then the disadvantages for using recursion are recursion's very confusing. So when you're actually trying to solve a problem on paper, let's say, before you actually start coding, if you're trying to think about using recursion, it's going to get very confusing. And also recursion is slower compared to loops. So if you can use loops, like a for loop, a while loop, or whatever, to solve your problem, use that instead of recursion because it's much easier and much faster. But like I said earlier, some problems, like traversing a tree, you kind of have to use recursion. Okay, so this is the basics of a tree. I'll probably go more in depth next week. But a tree is basically a collection of nodes connected by edges. So I found a really good diagram here that kind of just shows all the most important parts of the tree. So as you can tell, the first or like the highest node, or the we call like the circles are called nodes, is called the root node, right? Because that's like the beginning, the root. And every single node is, besides like the very bottom ones, can be parent nodes, and every parent node has a child, right? We call those children nodes, I guess, as you can see in the bottom left of the image. And the very bottom nodes, which don't have any children, we call those leaf nodes, right? Because like on a tree, you have branches, and the branches you have tree leaves, right? But leaves don't really have anything on them. Leaves are kind of like the end, right? So that's why we call like the bottommost nodes the leaf nodes. And the lines that connect all the nodes are called edges. And yeah, that's pretty much all the important parts of the tree. So here I have some questions I'd like you guys to answer. So we'll start with the first one. So what makes recursion different from other kinds of methods or functions? Like what's the most special part about recursion? You guys can either unmute your mic or type in the chat to answer the question. Come on, guys, I stated this in the first slide. What's the most important part about recursion? Yeah, you guys remember I stated this as like the first thing I said. No, the most important part about recursion is that it's a function that calls on itself. Because if you look at like any other method or like function or whatever, they're just like they just have one return and that's it. Recursive functions, however, they'll call on themselves and return multiple times. Okay, second question. What is the Fibonacci sequence? Like, does anyone know what the sequence is? This isn't really computer science related, but it will help with the next question. Now, does anyone know this sequence? If you guys don't know, just type no or like don't know in the chat so that we can skip the rest of this. Okay, so I'll quickly explain it. The Fibonacci sequence is that mathematical sequence where you add up, so you start from two ones and you go one plus one equals two, and then you just basically add the last two numbers to form the next number. So it's like one plus one equals two, and then now you have one plus two equals three, and then add up two and three to make five, and then you keep going. So that's just what the sequence is. Okay, next I guess we'll be moving on to pop culture.
Okay, so for pop culture today, we're gonna be learning about amusement parks. All right, so first of all, what are amusement parks? So amusement parks is, yeah, they're pretty much a park that is designed for entertainment. So amusement parks would include like stuff like attractions, like rides or games, and then also like food and restaurants, good dining places, shows, stuff like that. And then the most famous types of amusement parks are usually theme parks, which is, like I said, a type of amusement park, but it incorporates like a theme. So, for example, as we all know, like Disneyland, that revolves around, Disney, and then Universal Studios is revolved around, their production, their movies, and then there's also Legoland, which is obviously revolved around Legos. Yeah, so first we'll be talking about Disneyland. So there are like 12 total Disneylands in the world, and the biggest take place in Orlando, Paris, Tokyo, and California. So, like I said, Disneyland features a lot of Disney movies and TV shows. So, a lot of their rides include Star Wars, like Mickey Mouse, and then Indiana Jones. And then Universal Studios, like I mentioned before, is also a very big amusement park. There's five Universal Studios in the world, and the biggest are in Orlando in Japan. And then, yeah, Universal Studios is based on, their movies. And obviously, Harry Potter is a very famous movie. Transformers is also very famous. And then so is Jurassic World. And then, yeah, there's a lot of good rides revolved around this. All right, and here's the last one. It's actually Six Flags. So that answers your question. Six Flags is known as the thrill capital of the world. There's over 20 roller coasters in Six Flags, so very well known for its roller coasters. And then their fastest roller coaster is called King da Ka, which is goes at 128 miles per hour. So yeah, very fast. And yeah, that's it.
All right, for astronomy, I'm going to be talking about the moons in the solar system. All right, so assuming most of you already know what a moon is, but it's if you don't, it's basically just any nat they're basically natural satellites, which are any astronomical object um, which orbits a planet. And of course, Earth only has one moon, but other planets either have none or much more than that. And a total of 79 moons in our solar system. So, of the inner planets, which are like Mercury, Venus, Earth, and Mars, only Earth and Mars have moons, and Earth has the one large one, and well, Mars has two smaller ones. And then for the outer planets, those are those have much more, and they're much larger. Jupiter with 79, Saturn with 82, Uranus with 27, and Neptune with 14. All right. So for the first moon, I guess I'm covering, it's Ganymede, and among the many moons orbiting outer planets, half a dozen of them, by the way, are as large or larger than our moon. And the largest of them all would be Ganymede, which orbits Jupiter, which is the largest planet in our solar system, if you didn't know. And it has a similar size to planets, and is actually even larger than Mercury. Then we got Titan. It's also a massive moon, which orbits Jupiter. Um, it's the second largest planet in the solar system. It's also larger than Mercury, has about a radius of 1,600 miles or 2,575 kilometers. Yeah, that's about it.
So today we will be talking about the French horn. So the French horn history, the earliest French horn were also known as the lyre horns. They were made with ram horns and mainly used for religious purposes. At around 1650, the hunting horns were developed, which was an evolution from the earliest horns, and they were used during war times and also used as the first horn for musical purposes. Then it evolves into the modern French horns. So the anatomy of the French horn is in the picture. So the mouthpiece is is where you blow air. Is a small removable funnel-shaped device that helps to produce the sound by vibrating the player's lips and direct the airflow. It's made with different sizes and materials to fit the player's need. Most French horns are in F or B flat, which is commonly used in bands and orchestras. And the next slide, the finger hook is where you put your fingers and also to locate the palm and also put your fingers through the hook so you can put the keys. And there's the main tuning slides. So the tuning slides are located in the back of the horn, and it depends if it's a single horn or a double horn. The main tuning slides control the majority of the instrument's intonation, and the player moves this C-shaped other tubes to adjust the instrument's tune. And at last is the bell, which is at the end of the French horn. The bell, it's a flared end with where the instrument's sound waves are amplified and also shaped. It's the widest point of the instrument and it's designed to optimize the tone of the horn.
Okay, that's the end of today's lesson. Um, you guys don't have any more questions, then please fill out this feedback form and then you guys may leave. Thank you guys for coming.